I'm Ennemcien. We have seen the differential equation of simple harmonic motion as d square x by dt square equals minus omega square x. This omega is called pulsatance or angular frequency, which is given by 2 pi by period or 2 pi into frequency. Now, you can solve this differential equation that is beyond our scope. So, I don't try to solve it at present. We can take the solution. Take it for granted. From this, you can find x. We will get x as x equals a sine omega t plus phi. This is the solution or answer of this differential equation. Here, when sine omega t has its maximum value, that is 1, x will have its maximum value, that is a into 1, or x maximum equals a. So a is the maximum displacement of the oscillator from its mean position or resting position. That is called amplitude of vibration. Omega t plus phi. Omega is called pulsatance that I have told you. Omega t plus phi is called phase of vibration. Knowing the value of omega t plus phi, we can locate position of the oscillator. So it denotes the phase, the stage of vibration. Where is the oscillator at this time? That quantity is called phase. So omega t plus phi is the phase. Now at t equals 0, phase is omega into 0 plus phi, or phase equals phi. So what is phi? Why? Phi is the phase. Phase is an angle because it comes along with the sine function. Phi is the phase at t equals 0. T equals 0 means initial, starting. So phi is called initial phase of the vibrator or phase constant or epoch. E-P-O-C-H. Epoch. Now, look at this figure. This is a horizontal path along which a particle is executing simple harmonic motion. This is a resting position. It moves over to the right extreme position plus A, and from O it moves to the left extreme position minus A. So minus A and plus A are the amplitudes on either side of the resting position. At some point of time, let the particle be, oscillator be at P. Now we measure the distance or displacement of the position from O. So x is the distance from O, or OP is x. This x is towards right if the oscillator is moving to the right. At that time, the restoring force is acting towards O. So, suppose the value of epoch depends on the position of the oscillator at the start of your timing. That means when you start the stop clock, when you switch on the stop clock, where is that oscillator? That is the question. Suppose the oscillator is at its mean position when you start the stopwatch. That means at t equals 0, x equals 0. You put these values in the displacement equation. X equals a sine a sine omega t plus phi. This is known as displacement equation. You put x 0 in the place of x and 0 in the place of t. So you get 0 equals a sine phi. That means sine 0 is 0. So phi equals 0. That means displacement equation takes the form x equals a sine omega t. On the other hand, if you switch on the clock when the oscillator is at its right extreme or left extreme, that means at t equals 0, x equals plus a or minus a. Put these values in this equation, then you get a equals a sine omega t plus phi. Omega t is now 0. Put a in this place of x. So a equals a sine phi or sine phi equals 1. That means phi equals 90 degree. Now the displacement equation becomes x equals a sine omega t plus 90. That is cos omega t. So displacement equation general form is x equals a sine omega t plus phi. Depending upon the position of the oscillator when you start the stop clock, this phi will change different values. Two cases we have seen. In one case, you can take that displacement equation as x equals a sine omega t, where phi equals 0. And another equation is x equals a cos omega t, where phi equals pi by 2 or 90 degree, pi by 2 radian or 90 degree. So x equals a sine omega t or x equals a cos omega t. Both are equations of displacement equations of simple harmonic motion. Thank you.